coefficient of restitution. So this is something that Isaac Newton came up with. It's a measurement of the bounciness of an object. So here's an example. If we have here a pool ball on a pool table, or a snooker ball on a snooker table, and it's given an initial velocity, travels at that velocity, and travels and hits the cushion. Now when it hits the cushion, there's going to be some energy lost, and that's because the ball isn't 100% bouncy, I suppose. So it hits the cushion, and then the ball will reback with a velocity that's smaller than the velocity it hits the cushion with. So v will be smaller than u. Now, if you put one over the other, you'll get this value e, where e is the coefficient of restitution. And that's all it is. It's a measurement of how the velocity changes when an object rebounds off another object. You'll notice there as well that there's a minus in front of the v, and that's accounting for the fact that u and v are in opposite directions, so there's a sign convention that needs to be adhered to. Okay, so a couple of things about the coefficient of restitution. E, if e is 0, the ball won't rebound at all. And actually not just the ball, any object. So what will happen is the object will collide off the other object and stop dead. So that would almost be like a snooker ball hitting off the cushion, and then it just stops at the cushion. It doesn't rebound at all. The other case, which is a special case, is if e is equal to 1. And if e is equal to 1, what happens is whatever speed the ball hits the cushion with, it will rebound at the same speed. And we call that a perfectly elastic collision. I suppose e is equal to 0 then is a perfectly inelastic collision. And finally, e always has a value between 0 and 1, which we typically write as a fraction, but you can also write it as a decimal if you want. Alright, so let's use the formula. A ball travelling at a speed of 16 meters per second hits a wall. If it rebounds back at 12 meters per second, what is the coefficient of restitution? So my diagram will be like this. I normally draw the ball as it hits the cushion. So at the top part there is the ball hitting the cushion with a speed of 16 meters per second, that's to the right. It rebounds back with a speed v, v is 12 there, so that's to the left. That's my diagram. The quantities then, u is equal to 16 and v is equal to minus 12. Again, remember the sign convention. Put down your formula, e is equal to minus v over u, sub it in, and you get 3/4. So the coefficient of restitution is 3/4, and that's an acceptable value because it's between 0 and 1. Question 2. How about in this case? So if the ball hits at 16 and comes back at 16, remember the sign convention as well, and you get minus 16 over 16, e is equal to 1. It's a perfectly elastic collision, and there's no energy lost there whatsoever. Right, example 3. So the ball hits the cushion at a speed of 12. The coefficient of restitution is 1/2, and we're looking for the rebound velocity. So ball hits with a speed of 12, rebounds back with a velocity of v, which we don't know, and the coefficient of restitution is 1/2. Fill those into the equation. We get minus 6. The direction is the opposite to the way it hits the cushion. So if it hits the cushion to the right, the rebound velocity is to the left. And the velocity of the object is minus 6, but if you're asked for the speed of the object, you always take the positive value, which will be plus 6. So speed is 6, direction is to the left, and the velocity is minus 6. Velocity representing the combination of speed with direction. Alright, let's have a look at vertical questions. So, a ball is dropped from a height of 20 meters, it hits the floor, then rebounds back to a height of 5 meters. And the question asks, what is the coefficient of restitution? My diagram here has 4 stages to it. Actually, 3 stages, sorry. The 3 stages are from A to B, when it drops from 20 meters down to hitting the ground. My second stage is B to C, when the rebound occurs and when we need to apply the coefficient of restitution. And my third stage is from C to D, when the ball rises up to reach the maximum height of 5 meters rebound. Now what I'd like you to remember is that E is V over U, so we're looking at the ratio of velocities to get the coefficient of restitution. In the question we're given heights or displacements, and what that's telling me is I need to link those heights to the velocities. And because we know there's falling and there's rising and G is an acceleration, I can use v squared is u squared plus 2as. I look from A to B. So a couple of things. From A to B, it falls from rest, so u is equal to 0. That means the velocity as it hits the ground, the velocity at B squared will be equal to 2 by g by the height, which is 20 through which it's dropped. Now, I have v then is equal to the square root of that. So if I'm looking for the coefficient of restitution, I have one of those values. Now I need to get the second one. And the second one is the rebound velocity. So the velocity at C with which the particle can eventually rise to a height of 5 meters. So from C to D, I know that it reaches a maximum height of 5, and a maximum height, the velocity is equal to 0. So that's why I've got 0 on the left-hand side. The initial velocity there is the velocity at C, and the S value is 5 because it reaches a height of 5. Acceleration is minus g, which is why there's a minus there. Now if I rearrange that, I'll have two velocities. Of course, the semi-confusing thing here is that the v value is actually the initial velocity with which it strikes, the particle strikes the plane. So that's the velocity at B. And the final velocity in the coefficient of restitution formula is the velocity at C, which is actually denoted by the u. So I've got my two formula. I need to put one over the other. I'm going to put the v squared over the u squared, which is a quarter, and then I'm going to get the square root of both sides to get v over u. So v over u is e is equal to a half. Now remember that in the top box there, the v and the u should be reversed because the v value in the top one is the velocity with which it hits the plane, and that's actually the initial velocity hits the plane. And the u value in the top box is actually the rebound velocity. So that's the v value in the coefficient of restitution formula. Okay, I'll keep going. Maybe this will explain it a bit more if you're still a bit confused from it. So in general, what we have is v squared is equal to u squared plus 2as. And to calculate the velocity that it hits the floor with, squared, that's going to be equal to 2gh because the ball falls from rest. Then the ball might rise to a height h, it'll rise to a lower height because there's some energy lost. And if we apply v squared is u squared plus 2as again, we'll get 0 for the maximum velocity, or the maximum height. Velocity is equal to the velocity rebounding off the floor squared minus 2gx. Okay, if I rearrange the one on the right, it gives me that formula. The next step then is to use E is equal to minus v over u. Fill those in, and what we'll get is E is equal to the square root of the height, the rebound height, over the initial height it was dropped from. Okay, right now I want you to go to a video. I'll have the video up on Edmodo, and that video I want you to calculate the coefficient of restitution for all of the 4 balls.